All right, everybody. Welcome back. This video is meant to be watched before our very first class period. So watch it sometime before September 7th is our first day. Yeah, watch it before September 7th. What I'm doing in this video and what we will typically do in these short intro videos is we will begin talking about a new topic that we will cover in class that day. And we will do so by looking at this sheet, what I call an activity sheet. And we will just start off the activity sheet answering the first couple questions and giving some sort of introduction to a topic. Now, for a bit of context, before this semester, right? So if we were not living in a pandemic situation, we would often have a classroom in which students are sitting clustered together, working on activity sheets like this one, collaboratively, looking over each other's shoulders, probably breathing in each other's faces, all of that stuff that just doesn't fly right now. So instead, what we're going to be doing in class is we will be working on these activity sheets. We'll be collaborating as an entire class. And we'll do this in a manner that will become clear and that will introduce actually on that first class period day. So on that first day, you will get a copy of this activity sheet to kick us off. So this video will work through the first couple problems on the activity sheet, which are really just serving as an introduction to the topic itself. Now again, because this is the very first day of class, we don't have a new topic so much as we have a bit of review, or at least practice, right? This is going to serve to rip out those dust webs, spider webs, rip out those spider webs, clear off the dust, and to reintroduce yourself to some of those skills, those calculus skills that you have, but maybe you're just a little bit rusty on. And I have mixed a lot of metaphors there. So let's go ahead and get into it. My only goal for this video is to try to give you several different ways to think about the derivative and to remind you about two of the most important derivative rules, the product rule and the chain rule. So first of all, given a function f of x, what is meant by its derivative? Well, that is a loaded question. On the surface, we can say something like, well, if f of x is sine, its derivative is cosine. And you'd be completely right. But the derivative is so much more than that, right? There are lots of different equivalent ways to think about the derivative. So I want to start just with a English word definition of the derivative. So let me see here. So we can say, given a function f prime of x measures, I have to get used to the delay in writing here, measures the slope of the line that is tangent to f of x at a given point x. And I'll draw a picture to help explain what I mean here in just a second, once I finish writing this. Okay, perfect. So if we have a regular function, let's suppose we have a set of axes. Something like this. And let's say we have a function on blue. So we have a function, maybe it looks like this. So this is our function f. And let's say that we pick a specific place like right here. Let's say that that is the specific x value that we want to focus on. The derivative gives us the following bit of information. So at a point x, it will look at the function f. It will draw the tangent line at that point, right? So here is the tangent line, which I've drawn in red. And so the slope of this line the slope of this line is equal to f of x. I'm sorry, is equal to f prime of x. In other words, is the derivative of the function at the point x. Right, so f prime of x for a given x value is just recording a number, and that number is a measurement of slope. It's a measurement of steepness. It's a measurement of the slope of that tangent line. But of course, we also think of the derivative as a function, right? And that's because at different x values, you will get different tangent lines with different slopes. So you can set up a function in which you plug in an x value. And here we happen to plug in this x value. But if we plug in a different x value, we would get a different tangent line with a different slope, and therefore a different f prime. So f prime is giving us a different value at every different input, every different x value. And so it is a function in its own right. So when we said, for example, that the derivative of sine was cosine, that's a very, very true statement, but we see that because we draw the sine function, which I'll do very poorly here, right? Here's our sine function. That's f of x equals sine of x. So if we draw our sine function like that, and if we wanted to graph the derivative, which I guess I'll do down here in red, right, so this will be the graph of f prime, then what we would do is at each x value, so let's take a look maybe at this x value right here, we would go up to the function f, we would draw the tangent line, we would measure the slope of the tangent line, and we would record that number. At the x value I chose, this is a point with a flat tangent line, so its slope is 0, and so f prime of x is equal to 0, and so the height of the function there is 0, so I would just fill in that point. If I wanted to choose a different x value, right, so let's say rather than, yikes, what am I looking for? Here we go. Erase this, so rather than that x value, if I wanted to choose, say the origin, I would go up here, I would draw the tangent line, I would measure the slope of that tangent line. It turns out the slope of the tangent line at that point is 1. That's a line with a slope of 1. And so we would go ahead and draw f prime. That would be up here at a height of 1. I could do the same thing with other points. That's sort of a rough looking tangent line. All right, you could plot a bunch of points. Draw these tangent lines. You can measure their slope. Here's another point where the tangent line is flat, so its slope is 0. And we could sort of fill in the, fill in the dots, connect the dots, draw this for every point x, and the end result is function f prime. And oh, look at that. By connecting the dots, ooh, that did not connect. Let's try that again, a little slower and a little more respect for the technology. So if we were to connect these dots, it's like drawing with an Etch-a-Sketch. If we were to connect these dots, we would see that, in fact, this function is equal to the cosine function. So that's what we mean when we say that the derivative of the sine function is the cosine function. It's that the slopes of the tangent lines of the sine function happen to coincide with the, did I say that correctly? The slopes of the lines for the sine function happen to coincide with the cosine function. I believe I said that correctly. Okay, the final thing that I want to remind you of is that we have a bunch of rules associated with taking the derivative. So we talked about the derivative of sine is cosine, the derivative of x squared is 2x. There's a million of these. If we actually, okay, there we go. If we actually scroll down, we see all of these rules down here, right? So the derivative of sine is cosine, that's drawn right here. The derivative of cosine is minus sine. All these different rules are well worth remembering. 2 special rules that are also very much worth remembering, very important, the product rule and the chain rule. So as a reminder, the product rule said that if you have 2 functions, f and g, and then you go to take the derivative of those. You would get the derivative of f times g by itself, so f prime times g, plus f times the derivative of g. You would just get those. And that is our product rule. The chain rule said that if we had a composition of functions, and we went to take its derivative, so if we took the derivative of f of g of x, that's another notation for our composition, the end result would be f prime of g of x times g prime of x. So a lot of the challenge in computing derivatives comes from being able to remember all of these derivative rules and then use the rules in conjunction with each other. So if you had sine of x times x squared, how would you compute that derivative? You would have to use the product rule. How would you compute sine of x squared? You would need to use the chain rule. And so being able to go through these rules and use them to compute derivatives is challenging, but is much simpler with practice. And so what we're going to do a little bit on this first day is remember some of these rules, practice a little bit, and we'll do the same thing for intervals. That's going to do it for this video. Thank you so much. And again, I will see you on Monday for the first day of class.